let's take a look at other forms of equations of a line. So point slope form is very straightforward. Whenever you have a point and the slope of a line, you can go directly to point slope form. So in point slope form, we have y minus y1 equals your slope times x minus x1. Now it's important to see here that we are only plugging in for x1, y1, and the slope. This y minus equals, and then the parentheses including this x minus must stay there. They are part of the formula. They do not change. So you're only plugging in for y1, x1, and your slope. So I have a line that passes through the point -5, 2, and the line has a slope of 3/5. So going straight to the equation of a line, I have that this is my x1 and this is my y1 and this is my slope. So going right into plugging into the formula, I get y minus my y1, which is 2, equals my slope times x minus, and I plug in my x1, -5. Now I can simplify that. I can simplify the back term. We're going to simplify it as y minus 2 equals 3/5 times x, and this will become a plus back here. So I have plus 5. And that is my final answer in point slope form. Whenever you're given 2 points, you can find the equation of a line. You simply find the slope of the line that passes through those 2 points. Then you're going to pick one of the points and use your new slope to plug in a point slope formula. Now it does not matter which point you pick because both of those points exist on the same line. So yes, it might look a little different at first, but if you moved it around it would look the same, but in point slope formula it will look a bit different. So let's find the slope between these 2 points. You can go ahead and choose either one of them to be x1, y1, and then the other one to be x2, y2. Plugging it in to find the slope, we're going to have y2 minus y1 over x2 minus x1. Simplifying that, I get 6 over 2, which is 3. So my slope is 3. So I'm going to go ahead and plug right into point slope formula, which remember is y minus y1 equals m times x minus x1. And I can pick any of these points over here. I can pick either one. I'm going to show you what both of them would look like. So if I use this first point here, I would have y minus y1 equals my slope times x minus x1. And if I picked the second point, I would get y minus y1 equals my slope times x minus x1. And if you rearrange those, they would end up looking exactly the same, but both of them are correct answers and they are both in point slope form. So standard form is the last form of the linear equation we're going to talk about. It's ax plus by equals c. So this is a little different. X and y must be on the same side now, and then all the constants are going to be on the other side of the equal sign. We have a few restrictions on what a, b, and c can be, so the coefficients as well as the constant. A, b, and c must be integers, so they are not allowed to be fractions. So no fractions, no decimals, and then a is not allowed to be negative. So a must be positive. It must be positive. Now we also cannot have a and b both be 0 at the same time. So we have more restrictions on this form of a linear equation. Let's go ahead and write this in standard form. So remember, standard form is ax plus by equals c. I want all my x's and y's on the same side of the equal sign. So I'm going to bring my x term over by adding it to the other side. The x term is always before the y term, so when I rewrite it, I'm going to write 2/7 x plus y equals -3. Now I am not allowed to have fractions, so you can see that I have here this 2/7 fraction. So I'm going to go ahead and get rid of the fraction. Now how can I make the fraction go away? Now the 2 on the top is okay, right? So I don't need to get rid of the entire number. I just need to get rid of the 7 on the bottom. So I'm going to multiply every single term by the common denominator, which is going to be 7 here. So a 7 is going to be multiplied times every single term. So rewriting that, 7 times 2/7, these 7s are going to simplify, and I'm going to be left with 2x. The 7 will go to the y, so I get 7y equals, and then do not forget to multiply the right-hand side of the equation by whatever your common denominator is as well. So double check, I have x and then y on the same side, constant on the other side. 2, 7, and negative 27 are all integers, and then my leading coefficient here, a, is positive, so I am done. So here I have some decimals. So I am not allowed to have decimals because remember that's just another form of a fraction. So the first thing I'm going to do is I'm going to go ahead and move my x term over to the other side. So I have negative 9.1x plus y equals 3.6. So I have a few things that are wrong with this. I have a being negative, and I also have decimals. So how can I get rid of the decimals? Well, I can move that decimal place over and make this a 91 and this a 36 by multiplying by 10, because 9.1 times 10 is going to give me 91, so the decimal is gone. So you always multiply by 10 or however many decimal places you need to get rid of. So if I had one more decimal place, I would multiply by 100. So I'm going to multiply through every single term by 10. So I'm going to be left with negative 91x plus 10y equals 36. So no more decimals, so I'm almost there. But I have to deal with this negative right here. So to get rid of that negative, I'm going to multiply everything by negative 1. So everything's going to get a negative 1. So my final answer here, I'm going to have positive 91x minus 10y equals negative 36. So double check, I have my x and y on the same side. I have no fractions. A is positive. Now you could have just multiplied through here by negative 10, but I wanted to show you each individual step. So it's okay if you combine steps. Another way to graph a line whenever given your equation in standard form is by using the x and y intercepts. So the y-intercept means that this x term is going to go away, and the x-intercept means that this y term is going to go away. So finding the y-intercept, the x term will go away, so plugging in 0 for x, you can literally put your finger over the x term and it will go away and go to 0, and you can solve for y, and there we have our y-intercept. And for the x-intercept, now the y term is going to go away. So this whole term we can just pretend like it's not there. So we get 3x plus 5 times 0. That term now goes away. And we can solve for x. So 2 points is all I need to graph a line. So let's go ahead and graph our line. Make sure you label your intercepts. Draw the line between them as best as possible, extending over the coordinate plane. Label your axes, and of course label your line as well. So we do not need to switch to slope-intercept form. We can graph it in standard form using the intercepts. So here's a summary of the 3 forms that we have learned: slope-intercept, point-slope, and standard. So when 2 lines are parallel, What makes them parallel is that they both have the same exact slope. So they must have the same slope, but in order to be two different lines, they must have different y-intercepts. So parallel lines have the same slope and different y-intercepts. Now, perpendicular lines have opposite reciprocal slopes. So remember, perpendicular means that they intersect and form a 90-degree angle. So their slopes will be opposite reciprocals. So the opposite part means opposite signs. Reciprocal means that you flip it over to get the reciprocal. I want a line that passes through this particular point but must be parallel to this other line. So if I'm parallel to this line, that means that I have the same slope. So let's find this guy's slope. In order to find the slope, it needs to be in slope-intercept form. So I just need to solve for y. So solving for y, I can see that my slope is going to be negative 2/5. So since this line slope is negative 2/5, my new line slope will be the same because they're parallel. So putting this in point slope form, here's my point, there's my slope. So I'll have y minus y1 equals my slope times x minus x1. And there is the new line that is going to be parallel to that one and through the point 3,5. I want a line that is parallel to the y-axis through the point 5,3. So I need you to visualize what the y-axis looks like now. So here is the y-axis, and I want to be parallel to that. So a line that is parallel to that and goes through the point 5,3, so let's just say this is the point 5,3. I need to go through that point but be parallel to the y-axis, so I must look like this. Now the equation of a line that looks like this is always x equals, it's going to have an undefined slope, and I'm going to be x equal to whatever the x coordinate is that I hit the x-axis. Well, if the point is 5,3, then I must have an x coordinate of 5. So the equation of a line is x equals 5. I want a line perpendicular to this one, which means that my slope is going to be opposite reciprocal. So this guy has a slope of negative 4. So my new slope, I must change the sign. So now it's positive. And I must flip it over. So this one is over 1, so now I'm going to be 1/4. And I'm going to go through the point 8,5, so that's my x1, y1. So plugging it into point slope form, y minus y1 equals my new slope of 1/4 times x minus x1. And this is the equation of a line perpendicular to that line. So now I want a line that is going to be perpendicular to the y-axis, and it's going to go through the point negative 2,5. So here's the point negative 2,5. And if I am perpendicular with the y-axis, that must mean that I intersect it and create this 90-degree angle here, so I must look like this line. So the equation of horizontal lines are always y equals, and I am going to be equal to whatever the value is of the coordinate that I go through on the y-axis, which has to be 5 because I go through the point negative 2,5, so it's y equals 5. And this slope is going to be 0, so the slope of a horizontal line is always 0. Now it's your turn, so give these a try. And last but not least, graph this line.